Hi guys. Well, it's Sunday afternoon, so you know what that means. Time for me to start shooting this week's video. Okay guys, so in this video we're going to go over these very common tests that I run into on a normal basis. The first two are really easy. Checking battery voltage and the alternator charging voltage. Checking the voltage of just common wall outlets and your 220 outlets. Amp draw within the either in the CSCD or a load center box. Parasitic drain. That's the one that kind of really irks everybody because they're so hard to find. Continuity, checking blown fuses, things of that nature. Ignition system resistance, well, I have to go out to Emmett for that one. Troubleshooting a trailer plug, and then how to test capacitors, diodes, relays, both 4-pin and 5-pin. And the capacitors, we will actually do it using resistance and the capacitor mode on two different multimeters. And then we'll revisit the CSCD from episode 3 from when we hooked up the generator. A very common check is a check voltage on a battery. Very simple. You have your dial set to 20 volts DC. It means you can check up to 20 volts safely. Put your negative lead on the negative post and your positive leads, if I can get that to come in the camera, there it is, on the positive post. And I'm showing 12.61 volts. That's a good battery. A second test, I have to start the truck up for this, but it's to check the alternator charging capacity across the battery. Now, a 12 volt battery theoretically needs 13.1 volts to charge. You really want it to be closer to 14, 13.8, 13.9, somewhere along there. Now this is going to get pretty loud, so what I'm going to do is I'm going to start the engine, I'm going to come back, and we will do the check with the engine running, but I doubt you'll be able to hear me. For voltage in an AC system. So what you will need is a fork, and you want a bit. What? We don't use a fork for that? But this is fun. As with anything, before you start using a tool or a meter of any sort, you want to make sure it's in good working order. Now I know this is, so I just put fresh batteries in this one and this one this morning, and the clamp meter is only about a week old. So your black lead is going to go into your common port, and we're going to be checking voltage, so that will go over on this side. And if you're checking amperage, it will go over. There we are. It'll go over here. But since we're checking voltage, we'll be checking some resistance, diodes, continuity, etc. It'll be over here. Now we're going to use the AC function, which is signified by a wavy line. And we're only going to be about 110 volts. So that is plenty. If we was working on 3-phase, we'd be up around here about at the 600 volt mark. To check your AC voltage is actually very simple. You'll notice you have two different length slots in your outlet. This is your common, this is your ground, and this is the positive or the hot side. So take your negative ground, your negative probe, stick it in the ground side, and just take your positive lead and stick it in the shorter of the slots, and I'm reading 124.8 volts. So how does this work on a 240 outlet? Well, we have my 50 amp welding outlet here, and this only has 3 wires going to it. So you have your common, and then you have 2 hots. You have 120 on this leg and 120 on this leg. And you check it just like you do the 120 outlet. Stick your negative probe in here. Got 124.7 on this leg and 124.8 on this leg. Typically, you want them to be the same, but 1/10 of a volt is not enough to matter. So far we have been through check battery voltage and alternator charging. We have checked the 220 and 240 outlet voltage. We're going to save this for later as that. Let's do continuity. That's an easy one. Another test that happens quite often is continuity. Is something making contact? Is a circuit complete? So with the tractor off, I want to see if I have a blown fuse. To do that, you want to go down. You can either choose the continuity, or you can actually go into resistance. If it's showing OL on this particular model, the circuit is open. Once you touch the 2 probes together, you'll get a reading. As you can see, the fuse is good. While off camera, I purposely blew this fuse so we can test it and see how an open fuse would test. And as you can see, that's me touching them together, the probes together, and that's touching each leg of the fuse. That fuse is no more. So one test that I do a lot of, especially when I'm converting these old machines from 6-volt positive ground to 12-volt negative ground, is I have to check the resistance from the ignition switch down to through the coil and into the distributor. Having the resistance correct, within the correct range, will keep you from burning your points up and give you the hottest spark possible. So for this test, we're going to set to the 200 ohms setting. And then we're going to go from the ignition switch to the points. Which I have 3.3 ohms. Typically on a 12-volt system, you want to be somewhere between 3 and 4 ohms. So this is the meter I normally use to check amperage with. To check amperage, you have to have the meter in line, and that can be really hard to do with a standard multimeter. And this one just clamps around the wire. So to check amperage, all you do is turn it up to your desired setting. Now this is a 200 amp box. I could go to 400 amps, but I know I'm not pulling 200. So I'm going to put it on here on the 200 amp setting. I'm going to clamp it around one of the wires, and then I'm going to fire everything back up and let you see what the amp reading or what the reading's going to be. And I'm going to put it around that wire. And hopefully my cameraman will be able to get a reading or see the reading with the camera rather. So I went back inside the house. I've got everything turned on, and I'm pulling 21.3 amps. And I think the only major thing I have running at this moment is the dishwasher. It's drying a load of dishes. Let's go turn the dryer on and see if we can make it jump. So I went inside and I turned on the dryer, and you can see that it jumped up to 45 amps. Okay, so we are working on down our list. Now, I know that this is going to be the last thing we actually have in the video, even though it's already been shot. So we're going to take that off. And we've already done amp draw, continuity, and ignition system resistance. Let's work on testing capacitors, diodes, and relays. So there are two ways to check capacitance. One is a resistance method, where you actually use the resistance part of your multimeter like you'd be checking, well, resistance. And you can set it to different range of ohms for different class or different sizes of capacitors. The other way to check it is off of your capacitance section of your multimeter. We're going to do it both ways. So what I have here are three different capacitors. I have two DC capacitors, which are polarized, and I have one AC capacitor that's actually used as a motor starter that is non-polarized, which means you don't have a dedicated positive and negative pole. When you pick up a polarized capacitor, the side with the stripe or the shorter leg is your negative side. Now this particular capacitor reads 470 microfarads. So if we go to our list, your resistance setting needs to be on 20K. So to check the capacitor, first you want to short the capacitor out on your lead, and this discharges the capacitor. Now you want to attach your negative lead to the shorter leg, and then touch the positive lead to the opposite leg, and you will see it start at a very low. You'll see the meter, it'll be at a very low reading, and then will increase until it opens. When the meter gets to open, the capacitor is full of charge and indicates that it is operating as it should. This capacitor shows 33 microfarads. So we will need to set our meter at 200K. For this capacitor, the procedure is the same. Short the capacitor out. Connect the negative lead to the shortest leg. You see it increase until it goes to open, indicating this capacitor is good as well. Now this capacitor is an AC capacitor. In fact, it is a capacitor off the blower motor to the outdoor stove, which you will see more of in a future video. So it doesn't matter which one we hook the negative lead to, but you do still want to discharge the capacitor. It reads 1 microfarad, which is 2000 K. And sometimes that will be designated as 2 ohms. See if I can get that to show up on the. See, it's 2 ohms, 2 mega ohms. And the test is just the same. Hook your negative lead, and you see it increase until it opens the circuit, which means that it is operating as it should. We'll do it again. And being only 1 microfarad, it's going to get to an open circuit a lot faster. So to check the capacitance using a multimeter that has that function available, you want to set your dial to a setting larger than what your capacitor is rated for. This capacitor again is rated for 37 microfarads, so we can go down to the 200 microfarads and follow the same procedure. Short it out, negative lead on the short leg, positive lead on the opposite leg, and give it time to build. And we're showing 32.5 microfarads. It's rated for 37 microfarads plus or minus 15%. So 37 microfarads times 0.85, which is 15% below, is 31.45. We're at 32.4. That is a good capacitor. Lastly, we have our 1 microfarad AC capacitor. It's non-polarized, that's used as a motor starter. Short the capacitor out, and we can go down to 2 microfarads. And the same thing. And I'm showing 1.027 microfarads. That is a good capacitor. Next on the list are diodes. Now diodes are basically an electrical check valve. So any of you that have ever dealt with hydraulics knows that a check valve is designated like this, or something thereabout. And the premise is that electricity in a diode or hydraulic fluid in a hydraulic system would flow this way. It is hard doing this upside down. Let me fix this. Would flow in this way. coming in this way, it would pick the ball up off of the seat and allow hydraulic fluid to flow through. In electrical, same thing. This being the positive side, it's flowing to the negative side. Now, there's no actual mechanical ball to pick up off of a seat. It's all done electrically. But the premise is the same. So on a diode, and I just have a check valve up here for reference, a diode will have a stripe on one end of it. That is the negative side. The positive side is on this end. So it will allow electricity to flow in this direction, but not allow electricity to flow in the opposite direction. Now here's a little diode that I have. I don't know if you can actually see that. It's fairly small. But there is a stripe right there on this end. So there's really two ways you can check this. You can check it with resistance or using the continuity sitting on your multimeter. So we're going to take our diode here. The stripe is over here. This is the negative side. When I touch the positive side to it, we have continuity. Now I take that and I flip it around to where the negative side is on the positive lead, and you see that we have no continuity. It is only allowing the electricity to flow in one direction. And it's just using the little 1.5 volts that is, or 3 volts or whatever is in this particular meter, flowing through it to do the test. So next up, we have relays. As you can see here, I have a 4-pin and a 5-pin. And they both operate very similarly. So you're going to have certain numbers. You're going to have 85 and 86. And what 85 and 86 do, that is your control voltage. It can either be a lower voltage controlling a higher voltage, or it can be the same voltage but at a lower capacity. And that'll make more sense here in a second. Now I have a 5-pin here, and I tell you what, let's just change this a little bit. Let's make this work a little bit easier for us. And that's 85. It'll be up here. And then we're going to have number 30. Now number 30 is the load voltage coming in. So say you're coming from the car battery, whatever. This is the load voltage coming in. And you're going to have, on a 5-pin, you're going to have 87 and 87A. Now what this does, 87A or 87, depending on how your particular one is set up. Now this one's going to be 87A. You're connecting from there to there. So the power comes into 30, goes out through 87A. When you apply power to 85 and it flows, your control voltage flows in through 85, I think there's like a little resistor in here, and out through 86, it switches from 87A to 87. Let's set up a test so you can see this in action. So I am sitting on my continuity on the meter, and I have my positive lead hooked to 30. 87, is that 87A? 87A. 87A has continuity, 87 does not. So there's no power between 85 and 86. And the switch is over to 87A. I want to rig up a small 12-volt battery across these two leads, and then we'll see if we then have power on 87. So what I'm going to do now is I'm going to hook our lead, if I can get it over here, up to 87A, which shows continuity. When I connect the power to the relay, that should go to open circuit, which it does. Move to 87, there's no power on it and it's showing open. When I put power to it, I have continuity. When I take power off on 87, I don't have continuity. Power on, power off. 87A is exactly the opposite. Power off, I have continuity. Power on, I do not. A 4-pin relay operates much in the same manner, with the exception that you do not have 87, only 87A. So what you have is when there is no power here, this switch, see if I can get to the top off of this, is sitting out here somewhere. When you put power across the control pins or terminals, it makes connection. I'll again set up the previous test, but with a 4-pin, and you can see that work. So as you can see on this particular relay, I have a positive lead off the multimeter coming in to number 30. I have the negative lead hooked to 87A. I have my negative lead from the battery hooked to 86. And when I touch 85 with the positive lead of the battery, you hear it click, and then 30 and 87A have continuity. When I take it off, the circuit is open. Circuit closed, circuit open. Now some relays are normally closed units, where in use of put voltage to it, these two would normally be closed, and when you touch voltage to it, it will open. This particular one is a normally open, and when I put voltage to it, it closes. Okay, so we're just moving right on along here. Let's see what we've got left. So we have knocked out all of these. Let's go to parasitic drain next. So to check parasitic draw, I usually go to PowerProbe's website. I'm not endorsed by PowerProbe. I do have a couple of their products. I'm fairly impressed with them. The price is a little more than you're going to pay at other places, but the quality is definitely there. But anyway, just Google PowerProbe fuse voltage drop chart, and what it's going to do, they give you a page or two for each type of fuse. So this is the ATO ATC fuses. You got one for the mini fuse. What else you got back here? The maxi fuse. And there's even some for, I believe, micro fuses and possibly even glass fuses. Even the oh wow, I hadn't seen those in forever. And then yes, your glass fuses back here. But what you do is you set your multimeter to millivolts, and you check across your fuse, and then it gives you your amp draw in milliamps. And what that does is if you have something in your vehicle that's drawing power and killing your battery and you can't figure out which circuit it's on, well, you can narrow it down to which circuit by checking across all of your fuses in your fuse box. Now you expect to have some for like the clock on your radio, or there may be some kind of GPS module or something in your vehicles that's going to have very, very, very low drain. But that's designed into the vehicle. That's not what we're talking about. We're talking about something like maybe a short to ground somewhere that's allowing a little bit of amperage to flow through there and killing your battery over a couple of days. So to use this, we're actually going to go out to Emmett. I'm going to turn on something on him, probably the lights. And then we're going to do the test using this chart across the fuse, and so we can see how all of this works. Okay, so we're out here at Emmett, and what I'm going to do is this is the circuit for my headlights. Now I'm set in millivolts. I've got my headlights turned on. And I'm going to put the probes on the little metal tabs sticking through the fuse. And I'm showing 46.5.4, well, it keeps climbing, doesn't it? Let's just say 47 millivolts. Okay, so 47 milliamps. And I go on my chart here and I look up under a standard 20 amp fuse, and I come down to 47 milliamps. Well, these charts only go up to 10, so it's saying 2959. So I'm just going to say 3,000 milliamps per 10. So we times that by 4, we're looking at 12,000 milliamps, which is 12 amps. Then add 7 to it, which is, it shows 2,071 milliamps, or 2 amps. So it's saying we're pulling right at 14 amps on the light system on this tractor, which is about right, because my ammeter on the tractor, when I'm running it and I have my lights on, is showing somewhere between 12 and 15. A little closer to 15, but it's also running the ignition on this thing as well. So that makes sense. So shows that a 71-year-old ammeter is still fairly accurate. Okay guys, so another test that I have to do a lot of, unfortunately, has to do with the 7-way plug on the back of my truck and the tractor. Actually on the trailers as well. But you'll notice these don't line up. They're mirror images of each other. The receptacle is going to be on the tow vehicle, and the plug is what's on the trailer itself. So we're going to just ignore this one today, and we're going to focus on this one. Now when you look at the plug on the back of your truck or the back of your tractor, the little groove that this slides into may not be in the 12 o'clock position. It may be off to one side, or it may be on the bottom. So This is a determining factor of what the rest of these are going to be. Now, like on my truck, this is on the bottom, so that means that 4 is here and 1 is here, 6 is here, 5 is here, 2's up here, and 3's down here. Doesn't matter, just pay attention to where that is. So if I want to check, let's say, my 12 volt auxiliary, so I know that when I go to my truck, the 1 in the 1 o'clock position is going to be my ground, and the one that's going to be in about 7 o'clock position is going to be my 12 volt. Now, it's just me here right now, so I can check like my running lights. No real safe way to do that by myself. So yeah, let's just check. We're going to check the 12 volt. We're going to check the lights, just the running lights, and that'll be it. That'll be enough to show you how to do this. Okay, as you can see here, I thought mine had this on the bottom. Now it might be on the tractor, or it may have been on the old plug I had on this one. But I've got the negative lead hooked to my ground, and I am on the 20 volt DC. So I'm going to check my 12 volt supply, and I am showing 12.51 volts. Okay, this isn't the ideal setup, but you can at least see the display. So I'm checking my 12 volt now, and you can see I have 12.5 volts. So I'm going to go turn on my lights and see if we have voltage on the running light circuit now, which we do. Even though using a multimeter works extremely well, I suggest getting one of these plug-in testers. I've had this one so long, I don't even know where I bought it from. Probably Northern Tool or Harbor Freight, something like that. You can check the 7-pin and the flat 4. And you know, it's just not safe for me to test this on anything other than like my 12 volt circuit. And you can see that light come on for my 12 volt. But it checks your left turn, your marker lights, right turn, your backup light, your brake. So I have electric brakes on this, so I can step on it, that'll light up. You know, they're like 12, 15 bucks. Now, I don't think I even paid that for this one. Of course, it's been close to 20 years ago. But I highly suggest you, if you want to run, do any kind of towing or anything, get you one of these. Okay, so it's Sunday morning of the day I'm planning on releasing this video. I had to wait till most of the family was out of the house before I could kill all the power. We're going to go back into the CSED and go over some of the safety considerations and what I was working on during the generator install. Had some feedback, some people would like to see some more of that. So I'm going to take this panel off. I've already got the disconnect pulled inside the house. I'll turn this off, take this panel off, and then we'll be back. So here we are with the panel removed. Now, even with the panel removed, you still have power on those two lugs. The first thing I like to do whenever going into a box is I like to hook my multimeter up and test and make sure that my main lugs, pass-through lugs down here, are not hot. And then I like to test continuity between my ground panels and my grounding lugs. So for this test, you want to put your meter on the 200 volt AC setting. Now everybody thinks that, okay, your box operates up to 240 volts, and that is correct. However, you get to 240 volts by two legs. They're at 120 volts apiece. So actually, you're only working with 120 volts for each test. So the first thing I like to do is clamp my meter on to one of the grounding lugs. You want to avoid putting both hands into the box at the same time. Half an amp can kill you if it crosses your heart. So you want to try to hook your grounding plug in. So you want to hook your grounding lug in, and then I check continuity. You can go down here to your ohm setting or your continuity setting and just make sure I have good continuity between my common and my ground, as they're both hooked to the same block, and wherever my grounding plug is, which here it is showing that I do have continuity. Next, we're going to verify the meter is measuring voltage correctly by testing these two lugs. To do that, go to your 200 volt AC setting, because even though this is a 240 box, and we are dealing with 240 in the house, it's actually achieving 240 by two legs of 110. 125.3, 125.2, 125.3. So that's coming from the meter. Now we want to check our pass-through lugs and make sure there is no power on them. Nothing. Nothing. Now you're going to check the wire. Nothing. Nothing. You can even check your mounting lugs here. We're good. So for this test, you can see that I have turned the main breaker back on. And we're going to test 125.2, 125.2. Now if you're doing this test, you're probably troubleshooting a breaker. So to troubleshoot a breaker, you keep that on ground and you touch the mounting screws to where everything is mounted. Now see, this one is turned off. We should not get anything, and we don't. This is the generator breaker and should never be on when that one was on. That's what the whole last video that we did on the generator is about, how to hook that up. So I'm going to turn this back off. I'm going to open up our outlet box down here where the generator hooks, and we're going to do some continuity testing. And that will cover everything that was being done when the generator was being hooked up. Okay, so what we're doing now is we're going to check the continuity between our hot wires and the breaker, the ground wire and the grounding block, and from where it goes here to my grounding block up in the box, and the same for the common wire. As a rule of thumb, I always do ground first. So touch the screw, touch the block. Get up in there. And I'm showing continuity from the ground wire to the block. And I'm showing continuity from the block to the grounding strip up in the box. And next we will do the common wire. I'm showing continuity on the common wire. Now after you have shown continuity on both of these, you still want to do your pull test anytime that you're on the connection. Let's start checking our hot wires. So I'm checking it to the breaker, which I have continuity there. And I have continuity there. So first we're going to check our grounding wire, which we have continuity. This is checking the common wire. Now we're going to check the red wire, which is the top into the breaker, which we're good. And now we're going to check the other hot wire, which is the black wire. And it would help if I got it open. And we've got continuity there. So guys, I'm not an electrician, I don't pretend to be. So everything I showed you in this video is just based how I do things. You are ultimately responsible for your own safety. If there's something you would like for me to work on in the future, leave a comment below. If you have a comment about this video, leave it below. Okay guys, so I hope you liked the video. Don't forget to like and subscribe and hit the notification bell. And I'll see you next time under the shed.